This is a Hot Pie Media original.
How can we apply...
Creating superhumans.
Okay, that's what I was hoping you were going to say. Awesome. Yeah, awesome. That's all you had to say was superhumans, and I'm there.
Yeah, I mean...
Experiment on those sea lions. Experiment on them.
That's what really all scientists work on, is we're all I mean, we have annual meetings about creating superhumans. And so the cat's out of the bag now. Now you know.
And if you can't create superhumans, you guys have learned enough about technology that you can make some Iron Men.
Yeah, absolutely. Yeah. So, I mean, if we're not all in this for superhumans and Iron Man, I don't know what we're even doing anymore.
Hot Pie Media.
Stupid dumb beat made by G-Bro.
Welcome to the gray area. Here's your host, Aaron Cheatham.
Hey guys, welcome to the Gray Area Podcast right here with your boy Aaron Cheatham in the place to be. Got a super dope episode for you guys this week. You know what? You're going to be very happy that you came. Before we get into the interview though, I want to thank you guys for finding the channel again, finding the show. But help out your friends find it. Help out some people that you've never seen before find it. Hit that like button, subscribe, share. If you're on the audio platforms, make sure you hit the review, leave a review, give us 5 stars. You know, like Uber. I mean, you might think we're 4-star talent, but give us 5 stars a little bit. You know, help your boy out some. And then we'll pay it back on the back end. I promise you. At the end of this episode, you'll be like, you know what? It was worth the 5 stars and my review. But yes, do that. Look out for each other. We got a lot of fun happening for you guys. So without further ado, we're just going to jump right into it. Hey guys, we got a special guest on this week's episode of The Gray Area. I'd like to welcome to the show a marine biologist or ecologist. I've seen both online. I'm not sure if they're the same or different, but we're going to figure it out. We've got Dr. Craig McClain from Lumcon Sciences with us here on the show today. How are you doing, Dr. McClain?
I'm doing fantastic. How are you doing today?
I'm doing great. Is there a difference? What is the difference between a marine biologist and a marine ecologist?
It's basically who wants to give me a job at that time.
Gotcha. Okay.
I'll call myself whatever scientist gets me the salary. No, it is. So biologist is a more general term. You know, anything that's any science of the life on the planet, and then ecologist is specifically looking at how organisms interact with the environment and each other.
Okay. Nice.
So as ecology is kind of a subfield of biology.
Got you. So just a more specific term.
That's right.
Got you. Okay, well that makes sense. So we were going to do this interview a couple weeks ago, but we had to push it back because you guys had Hurricane Ida come through there, kind of muck up some stuff, and you guys
just a little
bit, right? Just a little bit. What part of Louisiana are you in?
So my home is in Houma, and the marine lab that I work at is in Cocodrie. So it's about an hour and a half to 2 hours southwest of New Orleans. We're in that part of Louisiana. When you look at it on a map, you don't know if it's water or land.
Yes.
And it depends on the day of the week, which of those two it is.
Okay. So you're not too far from the swamp people.
No. In fact, the marine lab's actually south of the swamp people.
Okay. Wow. I didn't know there was anything
possible.
south of that. Oh, man. Well, I'm glad you guys are up and running and doing well. But that kind of the storm coming in there was kind of part of why I wanted to talk to you from the jump, because it seems like we've been having more powerful storms coming through the Gulf of Mexico on a more frequent basis lately. My mom's still down there. My mom lives in Gulfport still, so I keep an eye on what's going on in the Gulf, because if anything hits the coast in that area, it's going to affect the whole Gulf Coast. You know, if you hit Louisiana, you're going to affect Mississippi and Alabama to an extent. So with that happening, was that a sign of global warming? The fact that we're seeing these stronger storms and that the storm season has lasted a lot longer than it used to historically. Are these all indicators that the water is getting warmer down there?
So it's as anything with climate change, is complex. So it's hard for us to say that, say, a Hurricane Ida this year, Hurricane Laura last year, the strength and the duration and the types of hurricanes that they were, it's hard for us to sort of attribute those specifically to climate change, to say, oh, the reason why Ida is so strong is because of global warming and climate change. Mm-hmm. However, we do know that climate change is impacting sort of the overall hurricane season, right? So as you mentioned, hurricane season is getting longer from start to finish. We're seeing more hurricanes, especially last year. The frequency of hurricanes last year. We were through. We had already went through an entire alphabet, and we're already into the Greek alphabet by the end of the season.
Yep.
And so the size of them, that they're kind of like their general nature. So for the example, like Harvey, is a big hurricane, dumped tons and tons of water, set records for how much rain it produced. The fact that it just sat there was kind of sloppy in many regards. Like those are all because of a consequence of sort of climate change in the Gulf of Mexico and, the equatorial Atlantic becoming warmer and staying warmer longer. And so we are going to continue to see this. Now, in the last couple of years, that's been exacerbated by us being in the La Nina El Nino cycle. So, in the last couple of years, although I just saw this morning that they're predicting that, I believe we're in the La Nina part of that now, that it's going to last longer, which means that next year's hurricane season is going to be another potentially large one.
Really? I did not realize that.
Unfortunately.
I didn't know El Nino was still a thing. I thought that was just something in the 90s. Is that a recurring cycle or something? What?
I like how it's like, you just referred to it essentially like they were a music group in the 90s that had like a couple of hits.
I didn't know they were still dropping.
And then they sort of went away. They're still dropping hits.
They're still touring? Really? El Nino still touring? Opening for Menudo still, right? Like,
oh, no, they're going to linger. Sorry, this makes me think of like the news yesterday about Smash Mouth, not basically the lead singer retiring. Because of some incident that happened at a concert where he was basically beside himself a little bit.
Smash Mouth is still a thing?
Yeah, well, that was my first reaction. I'm like, they're not already retired? Anyway, it's still El Nino, La Nina, not just a phase in the 90s, still going on. Still impacting our hurricane seasons.
Okay, well.
And so in years where we have La Nina, if I'm correct about that, we get longer and more frequent and stronger hurricanes, but the La Nina, El Nino cycles themselves are being impacted by climate change as well.
Okay. And that's like dry air moving. Is that what El Nino was? Like was that a dry air in the atmosphere pushing through, causing low pressure? I'm just saying words now. Is that what that was?
Yeah, I was just going to go along with you because this is not something all scientists will tell you, but like and I'm constantly reminded about this on the podcast that I do, where we talk about all kinds of science. Like I only know about one area of science, not like all of science, but then when I interact with people who are not scientists, they just assume I know every bit of science there is.
Yeah. My sister gets that. My sister's a nurse, and everybody in the family calls her with whatever element she has. She's like, I'm a cardiac nurse. I don't know why you have a fever. Call your doctor.
That's perfect. Yeah, I was in Massachusetts with my mother-in-law at one point. She was asking me like what trees were on the side of the road, and I'm like, I don't know. They're trees. Like I'm a biologist. What do I know about trees? Yeah. So yes, the La Nina, El Nino cycles have a lot to do with dry air and moist air and the cycles between those and cycling and temperatures.
I was okay.
And
so
of course, that has
right.
a huge impact on the climate of North America.
Okay. Another random question because you brought up,
and we'll stop there. So because we're like quickly approaching the level of my knowledge.
Got you. I noticed like you've done this though, because on your podcast, No Such Thing as Boring podcast, you had an episode about clouds, and you were talking about research our team you were part of that did some research on clouds on other planets. But you very abruptly said, that's all I know is just the clouds.
That's it.
That are there and that they exist.
Yeah, and it wasn't actually we were doing research on clouds. It was just my lab group, we are primarily deep sea biologists. And so we work on animals that like live under a lot of environmental extremes. And so knowing what we know about the deep oceans, that can be applied to the life that we might find in oceans on other planets and outside of our solar system as well. And so, so we were doing like, we're quickly trying to come up to speed on astronomy and astrobiology, which we didn't know much about. And of course, what were the conditions of these oceans on other planets?
Right.
And that was where I started finding out about like clouds on other planets, like methane clouds, sulfur clouds that just kind of circle around these planets. And but it was very quickly, that was like the end of my knowledge.
Like, that's it. I just know they exist and they're made of this. Don't ask me anything. Don't ask me thunderstorms. Don't ask me about rain.
That's right.
Yeah. Don't ask me how evaporation works on that surface. I just know they exist. So what drew you to marine biology? I mean, you grew up in Arkansas, a place where there's famously no oceans. What drew you to marine biology, though?
Well, I mean, I've always had an attachment to water. Like I grew up fishing a lot with my father, playing around the lakes and streams of Arkansas. I remember when I was a kid, like taking bread bags and trying to making homemade traps with bread bags and trying to capture fish with them. So I've always had an interest in water and the things that live in water. And so, when I was in college, I actually started off as pre-med. When you grew up in a rural part of Arkansas or rural lower socioeconomic region anywhere, you don't get that much exposure to science. And so I thought, if you're interested in science and you're smart, you become a dentist or a medical doctor, maybe an engineer. And so I didn't know that you could be a scientist. Like I didn't know that was a job when I was in high school. And so when I got into college and quickly realized that I was not pre-med material, and also that someone would pay me to basically play like in a lake or a river or an ocean all the time. I was just like, that's the job. I want to get paid to do that. And so, and then I took a scuba diving course when I was in an undergraduate, which sort of sealed the deal on it. I was just like, wait a minute, someone will pay me to scuba dive all the time and do all of this. And so, so that's kind of how it started.
Yeah.
And then just kind of pursued it in graduate school.
See, the extent of my knowledge of marine biology as a practice is going to SeaWorld. Like that's as far,
going to SeaWorld.
Yeah, like that's as far, like the people that work at SeaWorld with the animals. That's my entire experience with marine biology, and I understand that that's not like, I guess, real practical marine biology, like in the field marine biology. Those are not those are real animals, but they're not really studying them in their environment.
No, I mean, they're the people who work at aquariums, and there's different flavors of aquarium, right? And some of them, like the Monterey Bay Aquarium, like, they have these strong conservation and research sides as well. Georgia Aquarium as well. Mm-hmm. And so, the people who actually work with the animals, in the aquaria, they often have some sort of marine biology background or biology background. But they're primarily like marine versions of veterinarian assistants or veterinarians, or the marine version of a zookeeper. Gotcha. And so, a lot of times those aquariums will have research staff that'll be behind the scenes doing work. So for example, at the Georgia Aquarium, they have a research scientist there who, travels around the world and does work with whale sharks. And so, there is often these aquariums have like, research backgrounds. I guess it's depending on how we like. I think the answer to your question depends on how we define a marine biologist. Is it anybody with a marine biology degree? Is it someone who's actively working in any aspect of the ocean? There are different kinds of marine biologists. I'm a marine biologist who happens to do, have a PhD and do research, but that's by no means the only type.
But it's the better type, right? It's definitely the better type. You're not.
Oh, I'm living the dream every day, man.
I mean, at least you're not telling dolphins to flip, right? Like, so that makes you better.
I mean, I'm not a particular fan of dolphins in general, so that's probably
Why don't you like dolphins?
No, but I'm not Aquaman. I don't get to go out like in a boat and summon all the sea life to my will, as much as I try.
Well, this interview's over. That's what I thought you did. I thought you were Aquaman. Just going down to Atlantis and summoning all the fish to follow you.
That's right. No, I keep trying to call them to me and nothing ever happens. So yeah, just weird looks from the other people out at sea with me.
Good Lord. So what do you can you just tell me, like, talk me a little bit through like what a normal day is like for you in your branch of marine biology? Like, do you spend a lot of time in the water examining species and stuff? And what are, like, it's good that we have marine biologists, but what exactly is it that you guys do besides research? Or, like, can you just tell us some of that?
Yeah, I mean, let me start off with what a typical marine biologist does, because my job can be much different at times.
Okay.
Before my current position, as a typical marine biologist, most of my, I spend maybe once a week or maybe, anywhere to twice a week out on the water taking samples. So that's where I have an ongoing coastal program where I monitor the health of coastal organisms, especially invertebrates and things like that form the base of the food chain. So we go out and actively take samples and monitor, who's there and how many of those species are actually there. And that can be in response. And we look at how they're impacted by like Hurricane Ida recently and a variety of other, storm events or, after big flooding events like the Baton Rouge floods that happened in 2016 that pushed a lot of fresh water out into our coastal systems. We're also establishing that baseline data. So if another oil spill happens as the BP oil spill or some other environmental disaster, we'll have the baseline data to be able to understand its impacts. And so basically that project looks at the health of the ecosystem through time and how it's changing. And so then maybe once a year, I will go to spend 2 to 3 weeks out at sea, or sometimes longer. I've spent up to 3 months at sea doing what is more deep sea work. And so that is basically cataloging and trying to understand the diversity of life on the deep ocean floor.
Okay.
And so that's kind of like the field component, then of course, what may take me a day to collect or a couple of weeks to collect, then we'll spend the rest of the year in the lab, looking through the samples under microscopes, doing chemical analyses to try to figure out composition of their bodies. So we can figure out, food webs and who eats what. A lot of identifying of animals. A lot of the times when I do deep sea work, the animals are not known to science, meaning they've never been seen before. And so we have to basically identify them and figure out what animal group they're part of. What do they have a name? Do they need a name? And so, yeah, I mean, the sort of sexy part of any scientist career is I actually spend a lot of time on a laptop typing, papers, grants, emails, probably more than I would like to. So yeah, a lot of my day looks like like maybe any office worker. In fact, that I'm just staring at a computer screen most of the time.
So I'm curious about the the deep sea stuff. Are we finding, because you're in the Gulf of Mexico, do you guys find new species in the Gulf of Mexico? Are you finding any type of new stuff that's never been seen before down there?
Yeah, every time we go out and do deep sea work, and it pretty much is consistent no matter where you're at in terms of the deep ocean, I would say about 50% of the species that we find are completely new to science.
Really?
Yeah, there's still a lot of exploration to be done in the deep sea.
Like, how far down are you guys going that you're finding new stuff?
I mean, that could be at depths, even, as what I refer to as shallow, like at 500 meters, 1,500 feet. But, we do work all the way down. My group does work all the way down to like 5,000 meters or about, 15,000 feet.
Just for context, like, how far down do the mining platforms go? Like, are you guys going... I don't know how far it is to the floor of the Gulf of Mexico.
So the deepest parts of the Gulf of Mexico outside of the trenches is around 4,000 meters or so. And
okay.
So my understanding of the deepest oil rigs is they can probably hit like about 3 to 3.5 kilometers. So about, they're doing mining. They're doing test mining in the Pacific and through the Indo-Pacific islands that are around 4 kilometers deep or so.
Is there any evidence that the mining that they're doing has any effect on the deep sea?
It does.
Does it?
Yeah.
In which way?
Unequivocally.
How so?
Well, so deep sea life, because of the cold temperatures, is slow growing and has very long lifespans. And so any disturbance that happens in the deep sea that may kill organisms off, it'll take a while for those species to grow back, basically. And so, anything like deep sea fishing to deep sea mining that is removing organisms, it takes a long time for deep sea ecosystems to recover from that. And so that means that any impact is going to be greater in the deep oceans.
Okay, that makes sense. But
and especially because a lot of these practices, like deep sea mining is extremely destructive.
So we're possibly destroying the habitat of a lot of these animals that live in the deep sea that we don't even realize are there.
I was going to say exactly that we're destroying species before we even know what's there.
Would it be advantageous to send you guys out to do a study for a year or so before they create one of these platforms? And
they are required by several sort of international regulatory bodies to do environmental impacts beforehand.
Okay. Do the with the warming seas, are you guys seeing animals that are deep sea, maybe moving further deeper because of the warming temperatures on the top of the seas?
Not so much, because the pressure of the oceans limits how deep things can go. Things are really adapted to live at a specific depth, regardless of what the temperature is. But we do know that the deep oceans, they are sort of like heat sinks. And so even in the deep oceans, we know that the deep oceans, far removed from the surface, are starting to warm up.
Wow.
And in organisms that are essentially cold adapted, most of these organisms are used to living near freezing. So even minor changes in the temperature is going to have really significant impacts on deep sea life.
Which would then, in fact, it would affect their, I guess, the food supply, because if they have to move deeper to stay colder, they might be losing out on some food that they would normally be eating that's a little bit higher.
That's right. Yeah. So the deep oceans, there's, because of the lack of light, there's no photosynthesis, no plant life. And so most of the food in the deep sea is stuff that sinks from the sea surface and falls down to the ocean floor. And so what arrives actually the ocean floor is just, a small fraction of what was actually produced at the surface. So, we often think of the deep oceans for the most part as being food limited. And so not the kindest environment with the cold temperatures and the high pressures, and as well with the the limited food. It's amazing that there's life there at all, to be honest with you.
If you got a fish from the deepest part of the ocean and you zipped it up to the surface really quickly, would it explode?
It depends. So yes, with fish, but not all. There's a colleague of mine at the University of Hawaii who actually built a fish trap that keeps fish under pressure. And so they basically create this huge pressure vessel that they put on the deep sea floor, and then they trap a fish in it with bait, and then it closes up, and then they bring this whole pressurized vessel to the surface so they can do physiological experiments and things along that line. Now, there are organisms that you can bring up from the ocean floor, and as long as you keep them cold, can survive in aquaria, in a lab. And so anything from, snails to octopuses to,
Are there deep sea octopuses?
There are deep sea octopuses.
Is it octopuses or is it octopusi?
It is whatever you want it to be.
Okay.
No, seriously, it could be equally correct is octopuses, octopi, and octopodes, if you want to go Greek on it. Well,
that just sounds racist. I'm not calling anybody an octopode. That's, I'll get canceled for that, Craig. I'm not doing that.
Wow, this podcast is really all over the place, isn't it?
We're just having fun. I'm just trying to learn and have fun with you. Okay, so there are octopuses down there.
There are. Yeah.
I did not know that. I thought maybe squids were more deep sea than octopus.
And there are squids as well. Yeah.
Okay, and so I watched Shark Week once, and they talked about like
this feels like I researched vaccines on the internet for 5 minutes. It feels like that kind of question's coming.
I watched Shark Week once, and they talked about sharks that some sharks that can go down into the deep ocean and come back up. Are there other animals besides sharks that kind of spend part of their time going between deep sea and normal sea?
Yeah, so seals, sea lions,
really,
a lot of the whales will feed deep and come back to the surface. Penguins are known to dive. Some of the penguin species are known to dive pretty deep as well.
For real?
Yeah, absolutely. Yeah, we were using remote operated vehicles for this underwater robot at about 2 kilometers down off the California coast, and as we're doing the work, a sea lion swam by. In the video, like we were sitting there just dumbfounded to see a sea lion that deep.
Yeah, because it's a mammal. Like I would not expect that mammals, because you talked like what you said about the further you go, the more pressure there is. I didn't think that a mammal's body could handle that pressure of being able to go down there.
Apparently, they have a whole host of adaptations to allow them to do just that. But it was still pretty. It was jarring to see. Actually,
has anybody like done research on these animals, on these sea lions, and seeing why they're able to?
There's a whole group of marine mammalogists who basically study these deep diving behaviors, right? Because the physiology that allows animals to do that is like really fascinating. Like, how do they, and it's not just the ability to withstand pressure, it's the ability to hold oxygen that long while they do these deep dives.
Right. Wow.
And you can think about that, like you can uncover the physiology that allows both for that kind of oxygen retention and the ability to survive that, well, also the temperature and pressure. Like there's lots of biomedical applications for that.
How, like what? How can we apply?
Creating superhumans.
Okay, that's what I was hoping you were going to say. Awesome. Yeah, awesome. That's all you had to say was superhumans, and I'm there.
Yeah, I mean,
experiment on those sea lions. Experiment on them.
That's what really all scientists work on is we're all. I mean, we have annual meetings about creating superhumans, and so the cat's out of the bag now. Now you know.
And if you can't create superhumans, you guys have learned enough about technology that you can make some Iron Men.
Yeah, absolutely. Yeah. So, I mean, if we're not all in this for superhumans and Iron Man, I don't know what we're even doing anymore.
Can you talk about some of the technology you guys use to pull off some of this research, especially, like how you're cataloging and viewing all of these deep sea or just organisms in the sea, period? Because, I mean, you can't just sit on the surface and go, oh, there's that. But, I mean, through Shark Week, this is really all my marine biology is SeaWorld and Shark Week. This is why you're here, so that I can not be an idiot and I can learn about, like, I can have real.
Now you can add one more into this. I was talking to this marine biologist once.
Yeah, I gotta have 3 points of references. It's gotta have 3 points of contact.
Right.
3 points of contact. But I've seen technology, like when I was a kid in the 90s watching Shark Week, as opposed to showing Shark Week to my kids now. You can see that there's better technology for getting down in the water and observing marine life. What type of cool things do you have now that help you guys out in cataloging and researching marine biology?
Yeah, I mean, the workhorse for most of us deep sea biologists is what we call a remote operated vehicle, which is basically a tethered robot, at the end of this huge powered fiber optic cable. And we can set in a control room on the surface vessel and basically see everything that goes on in the deep sea floor. And, I remember earlier in my career having that kind of technology available to me, but like the cameras were like these grainy cameras and you couldn't really make out a whole lot. And now, we're getting everything back from the sea floor, kilometers below us, in 4K ultra.
Really?
And yeah. And so we're watching these on these, beautiful flat screen TVs, and it looks like a window. I mean, it's that crystal clear. And the cameras allow us to like zoom into, almost a sub microscopic level. And, and these robots, they have, they have manipulator arms. And so they're able to grab and take samples, and we can devise new kinds of sampling devices to, to capture stuff, and kind of cruise around, we also have, there's much fewer of them, and they're extremely more complex, but we still use submersibles. And so the most famous of those deep sea submersible is the Alvin out of the Woods Hole Oceanographic Institute. And in fact, my lab group, we did dives in that submersible just last year. And
Okay.
so, that again, it's just like, you're putting 3 humans in a titanium sphere and taking them, kilometers deep. That's an amazing and impressive bit of technology.
Yeah.
And now we're increasingly doing more autonomous vehicles, so these robots basically, we set them with a program and kind of release them into the ocean. Then they may, run along the bottom and map the ocean floor, or monitor chemistry, like things like temperature and salinity and things like that. Or some of the better ones will even like take video. And so they'll have a video camera down mounted and be able to like just keep cruising along the ocean floor, taking video, looking, for animals and things like that. And so, then lots of my colleagues, have developed things that allow us to like, pressurized traps that we can bring, deep sea fish to the surface to be able to study them. Or a colleague of mine developed a piece of equipment that allows you to take like metabolic measurements, like the respiration rates of animals, like actually on the sea floor.
Whoa, really?
And so, yeah, and they actually deployed that down into a couple of trenches. So, we're talking like the deepest parts of the ocean. So, yeah, every year, it's like something, there's like this like a bit of advance that allows us to like uncover more of the deep ocean just by it being more accessible.
Do you think it's would it be better if you could actually get humans down there to do the research themselves, or do you think that these autonomous devices are able to do just as good of a job?
I think there's room for both. There's advantages and disadvantages. I mean, I will say that I've used a lot of like remote vehicles throughout my career. They, you can keep, what I like about them is that, they can stay on the bottom sort of indefinitely, because on the surface, you can rotate in and out pilots, in and out scientists, because you're on the surface, you can have a bigger scientific team with a wider range of expertise, as part of any sort of dive. And so there's lots of benefits there. It's also safer because there's no human element that you're taking to the deep ocean. But after, saying that, I mean, sites that I've been working on for years, last year we got to actually visit them in a submarine, and staring out a porthole at the places that I've been at multiple times with ROVs was a fundamentally different experience than seeing it from the ocean surface, And so, I mean, I think one of the big things is you don't get a sense of like, when you're watching things through a flat monitor on the surface, you don't get a spatial awareness that you do when you're actually like driving around on the seafloor yourself.
Right. We have NASA famously, which, is kind of when people think about space and space exploration, space science, they think about NASA. But we famously know more about the stars than we know about our own oceans. Is there an organization kind of like NASA that's like the forefront of exploring and researching our seas?
In some regards, for the U.S., that would be NOAA. But NOAA has a mission that's slightly different than that, right? So they obviously have this atmospheric component, and there's also like more of a conservation restoration focus to them. And so and NOAA is very important, and they do have a part that's exploratory, but not in the same way that NASA's mission is fundamentally exploration, right?
Mm-hmm.
And in fact, a few years ago, a group of colleagues and I actually advocated that we needed essentially an ocean equivalent of NASA.
Yeah.
That doesn't currently exist with a pure exploratory mission.
I could definitely see the benefits of that, because I've always found.
But you could.
Oh, go ahead.
Go ahead. I'm sorry.
Oh no, I was going to say I found it weird that we know more about external things than we do our own stuff. I think that's weird when it comes to the human body and how we know more about things around the earth than we do what's going on inside the human body in some cases. And I find it very odd that we know more about what's going on in space than we do what's going on under our own oceans. And I feel like there should be some research put into that.
Yeah, I don't know if I necessarily agree with the idea that we know more about planets and the moon than we do the deep oceans. I don't think that that's actually
really
true.
Okay, no, please correct me.
I've heard that several times, but like there's lots of exploration still to be done, and we, like I said, we're constantly encountering new species and new environments. Hydrothermal vents, one of the were only discovered in like the late 70s, and so and we're still describing not just like microscopic animals, but like big charismatic animals that we had no idea existed. For example, you know about the Yeti crabs?
No.
You don't know about Yeti crabs?
I don't know about Yeti crabs. What's a Yeti crab?
No, you're going to have to Google this because you won't believe it. So there are these white crabs that occur at some of the hydrothermal vents. They were first described off vents off of Antarctica. And so their claws like have these, like, they look furry. Like they have furry claws. Oh. There's no other way to describe it. And so those furry elements are actually not their fur. They're actually bacterial filaments. But they look like they have like, oven mitts on, furry oven mitts. There's actually one of the other versions of the Yeti crabs called the Hoff Crab, because like its chest is hairy. That's where it keeps its bacterial filaments. And so it looks like it has like chest hair, like David Hasselhoff. So they've called it the Hoff Crab.
I assumed that's what you meant by Hoff. I was like, please don't go. Okay.
No,
awesome.
That's where that was going.
Awesome. We're going straight to the Hoff, huh? We're going right to the Hoff? Got it.
Yeah.
I just looked at a picture of one of them. They're freaking crazy.
I know. So those were only discovered within the last like 10 to 15 years. And so, in the last decade, we've discovered a snail that occurs at hydrothermal vents in the Indian Ocean that actually incorporates iron pyrite into the foot. So when you see a snail crawl across the ground, the soft part that's actually moving across the ground is called the foot.
Yeah.
And so it actually builds up these like iron pyrite plates across its foot for protection. It looks like a little samurai snail, for lack of a better description of it.
Really?
Yeah, it's one of the few organisms, if not the only organism we know that actually builds metal into its skeleton.
So it's like Wolverine.
Yes, it's just like Wolverine.
Hell yeah.
So if we can study this, we can really create superhumans. That's where this conversation is going back to now. Yes.
Oh man, I'm gonna start a petition that we get these Wolverine snails up here on the surface so we can figure out how to do this.
It's funny, after all these years about knowing those snails, never once did I make a connection to Wolverine. I need to come on your podcast more often.
Done.
Just for your insights.
For how I see the world. Got it.
Yeah.
So one of the big discoveries recently, and actually the whole reason you're here, it was tardigrades. And I don't know how recently they were discovered. All I know is that they became a big talking point over the summer for me because they had a whole display about them at the McClain Museum down in San Antonio. And I took my kids and they got to ride on a tardigrade and all this. And all I really know is that this is a microorganism that looks like a bear, but they have the ability to slow their metabolism down to where they're invincible. Like they're what's the word I'm looking for? That they don't die. Like there was some that were frozen in ice for 2,000 years, and when they were thawed out, they were then alive again. What is the deal with? Is this a big? There's so many questions about tardigrades.
So,
what is a tardigrade and why is it?
Well, that's pretty existential. I don't know if I can tell you why tardigrade, but so So tardigrades have actually been known for, I think they were discovered like in the late 1700s.
Really?
By a German scientist. Yeah. So that there's about, I think, close to 1,000 known species of tardigrade, if I'm correct on that. Yeah. Like you said, they're weird. I mean, that's part of, I think, the fascination. They're weird, but they're kind of cuddly weird.
They're cute.
Like, yeah. And so they're kind of a cross between like a bear and a pig, but they have 8 legs. Yeah. They're
looks like fingers on them.
They're tardigrades are, yeah. And so they're called, so they're often called water bears, or Carl. I like moss piglets a little bit more, because so they're found in they require like a wet environment. And so a lot of them tardigrades are known from, they live on the water films that occur on moss.
Okay.
And you can find them in like wet soil. They occur in the deep oceans and coastal oceans. They kind of occur everywhere. And they have this amazing ability to basically, when things get bad, to kind of just go into stasis and wait it out.
That's not a bad
until conditions
idea.
become favorable again, and then they sort of reanimate. Yeah. They're really weird.
I've done that in several relationships. Just go into stasis and wait it out. This will be over soon.
That's terrible. Oh, that's so bad. If I just wait here for a while and not interact with the outside world, it'll just leave me alone and go away.
It never works.
Yeah.
Never works.
I was about ready to ask you if it has ever worked.
Nah.
Have you just went into stasis and that girlfriend went away and another girlfriend came in?
Well, remember when I told you there was some showers in cold showers in apartments with no electricity? I kind of went into stasis hoping that the bill would go away. And it didn't.
I've tried that several times where I've just hoped, if I just put tuck this bill over here, surely, everyone will forget about it.
Yeah, if I stand real still and I don't do anything, they won't even know I'm here anymore. They'll just let me live my life.
If I don't make eye contact with the bill, no one will know.
It's like Drax the Destroyer.
That's
I'm moving so
me.
slowly, eating this chip. Like how can you see me? Just you're there. We can see you.
Oh, that's too good.
Oh man. So are we learning anything?
I've
from
totally
them?
lost my train of thought now on tardigrades.
Have we learned anything from tardigrades that might be of assistance to help us understand the oceans more or microorganisms more?
Well, I mean, I think again, it's like with these organisms, and it can, tolerate and are adapted to extreme environments. Like if we can learn more about their physiology and how they work at a molecular level, that opens up a broad suite of, biomedical applications. Right. And so the question is like, how is it that a tardigrade can go into stasis, right, and survive so long and then be reanimate? And you can think about like, if we can understand that process, we might be able to, eventually be able to suspend humans that we're not able to treat, now, like, in severe life-threatening conditions, and reanimate them later when we have, either temporarily later when they have access to better medical facilities, or alternatively, in the future, so to speak, like in a kind of cryogenic sense. And so, again, understanding how life works at these extreme conditions, how do marine mammals dive to so deep and able to tolerate that? And, all of this stuff has a very applied angle.
So I thought we already had that technology. Like the Illuminati was already cryo freezing billionaires and waiting for us to figure out how to cure cancer to bring them back.
I can neither confirm nor deny anything the Illuminati is doing.
I don't think anybody can. But is that real technology that we could possibly learn something from these microorganisms, from tardigrades? Is that the thing about them that makes them interesting from a scientific perspective?
I think those biomedical applications is why there's a lot of tardigrade research going on. Why the public's interest in tardigrades? I mean, I think it's just because they're such a bizarre animal. Yeah. There's some other things. I mean, I think they're interesting from a genetics perspective. So there are these sets of genes called Hox genes.
Okay.
And HOX genes. And so what they do is they basically code for a region of the body. And so there's like a set of Hox genes, like if we think about arthropods, like crustaceans and things like that, which is where tardigrades, branched off from evolutionarily. There's a set of Hox genes that codes for the head, and there's another one that codes for the thorax and the segments and the abdomen and that area. And then there's another one that set of Hox genes that codes for the tail. So that they're basically like the Hox genes basically code for like big components of the body. Well, the interesting thing about tardigrades is actually they don't have very many Hox genes, and most of the tardigrade body actually developed out of the Hox genes that actually code for the head in other arthropods. And so like the tardigrade outside of maybe the last set of legs is all like basically developed out of the head region.
That explains why it doesn't have a face, because it's all head.
It's all face.
It's all face with arms coming off of it.
All face.
Oh, I know.
Yeah,
I knew a kid in elementary school called All Face. He had a big old head. I'm trying to tell you. That's okay.
Yeah. So, I mean, there's such bizarre creatures in so many different ways that I think, scientifically, that's where the interest is. And they kind of work a little differently than a lot of other organisms.
Do microorganisms have like a schedule or a routine that they follow, or do they just kind of aimlessly wander around doing stuff? Like
do they keep a Microsoft calendar?
No, do they go to sleep? Or do they like at this time of day, we know we can find him in this area of the Petri dish doing this thing, and at this time of day, he'll be on another part of the Petri dish? Or do they just bump around?
So, I mean, I think that they cue off the environment, right? So if there are cycles in the environment, then microorganisms have a cycle.
Okay.
And so if there are day and light cycles, then microorganisms will cue into the day and light. Or if there's tidal cycles or annual cycles because that affects things like temperature. It affects food supply, affects currents. So, I mean, most organisms have some sort of temporal cycling but that temporal cycling is often linked to the environment in which they live in and the temporal cycling of that.
This might be outside of your field, but I'm going to ask you anyways. Is there consciousness on a microorganism level that you guys have seen any evidence of?
That is totally outside my field.
Okay. Okay.
But I'll make something up for you. I don't think so. I mean, I think it depends on, there's probably multiple definitions of consciousness.
Fair.
And it depends on what you define as consciousness.
Fair.
But I would say, if we mean consciousness as self-awareness, probably not.
Okay. So they're not very disappointed with their accommodations.
I mean, I guess it depends on, I think it depends on the microorganism and what condition they're living in.
Okay. Fair enough. Dr. McClain, it has been a pleasure. I really have learned a lot in this conversation. As much fun as we've had, it's actually surprising that I came away actually feeling smarter from this because we were having too much fun. Can you tell people where they can find your podcast and tell them a little bit about Eden and your podcast?
Sure. So I have a podcast that's released monthly called I don't even remember the name of it anymore.
Oh, Lord.
Called No Such Thing as Boring. And every month we tackle a new boring topic in science and try to convince you that is actually interesting. It's a lot of fun. It's done with a wonderful friend and colleague of mine, Eden Robbins, who's not a scientist. She's actually a novelist and an essayist. And so, you can find that on any platform you basically listen to podcasts at.
I would recommend checking it out, guys. If you've enjoyed our conversation here, you're definitely going to enjoy his podcast, No Such Thing as Boring, because I feel like that's why I had to have you on. I was like, I feel like I learned something and I didn't realize I was learning something while listening to your podcast. So I appreciate that. If people are trying to find your research or any information about what you guys are doing out there, where can they find you online?
Yeah, so you can go to craigmcclain.com, CraigMcclain.com, which is my research website. If people are interested in more about, I serve as the executive director of the Marine Lab here in Louisiana. You can go to lumcon.edu, lumcon.edu to go learn more about that. And I am on Twitter at DRCRAIGMC. So you can find me there.
And do you have a aquarium on the Gulf Coast that you would recommend for people to check out?
So I'm biased. A good friend of mine is the overseas research and education at the Georgia Aquarium. Love the Georgia Aquarium. Would recommend people go see the whale sharks there.
Okay, dope. Is that like around Savannah?
In Atlanta. In
Atlanta?
Right in downtown Atlanta. Yeah.
Okay, I'll have to check that out. I got to take my kids to an aquarium, so that's a good enough answer. We can stop in Atlanta for that. Dr. Craig McClain, I appreciate you coming on, brother. It's been a pleasure, and I hope we get to speak again. I'd love to have you back on the show another time. You've been a wealth of information.
Thank you so much.
Thank you so much. You take care of yourself, and y'all be safe out there on the coast.
I appreciate that. Take care.
All right, take care. All of science is about making superheroes, G. And the more he talked, the more I understood all they're trying to do is make that's what all of this is about. Like everything we talked about, I was like, yo, stasis, freaking all the technology, the suits they're making, they're trying to get, there's a goddamn snail with metal. Bro, he was so right. All of science is about turning us into superhumans. I hope you guys got that. I hope you got that from that interview, that this whole thing is about not us. I'm not going to be a superhuman. My kids probably won't, but maybe my kids' kids can walk around on feet that turn into metal when they touch ground. How gangster would that be? Yo, that was dope. Dr. Craig McClain coming through, dropping knowledge. That was so much fun. Make sure you guys check out his stuff. Wow, I've been looking forward to this interview for legit, you guys don't even know, for like a month and a half, 2 months, I've been looking forward to this interview. Been sitting on pins and needles, holding this one in reserve, waiting for us to have this. And I'm so glad we got him in. And he was everything that I could have hoped for. I was looking into his eyes and I was just like, man, I should have took science serious. That's what I should have did. I should have studied. I should have went to lab. I could have been having fun. Instead, I'm on stupid stages, telling stupid jokes to stupid people, trying to make them do their stupid laughs. I could have been in the water, G. I could have been in the water, fucking around with a samurai snail and a Yeti crab. Did you look at the picture of the Yeti crab? Oh, excuse me. I knew what the Yeti crab was. Oh, I'm the only uninformed motherfucker in the room today. Got it. All right, well, guys, go look up a Yeti crab. G's not going to put one on the screen because he assumed everybody already knew what a Yeti crab is. Oh, you just heard of the samurai snail? Yes, I just heard of the samurai snail. I'm a fucking comic. Geez, that was great, man. Man, I am pumped up. That was so much fun. Thank you guys for tuning in. Thank you for watching this episode. If you enjoyed it, please hit the like buttons, share, subscribe, enjoy, thumbs up, all that stuff. I couldn't be any more over the moon after talking to Craig. That was so much fun. Like, I am to the moon right now. Like, I am feeling it. That was good stuff. G's pumped up over there. Y'all can't even, I ain't never seen a brother crip walk on some science. he was just sea walking on some science. He's like, y'all know about neutrinos in this mother. I ain't never seen somebody sea walk to science. He didn't even have a beat. He was just like reciting the periodic table. He was just, boron, fool, boron. What you know about cobalt? He was just out there. Wow, that was great. That was great. Thank you guys so much. As always, you can follow us on the Instagram and the Twitter. Instagram is @Podcast the Gray Area. Twitter is Podcast Gray Area. I'm on the Instagram and Twitter _Aaron Cheatham. Follow us on the Facebook, all that stuff. If you're in the Houston area, I will be there November 5th through 7th for Skank Fest. I'll be in Fort Worth next week. Probably by the time this comes out, I'll already be there. Be in Oklahoma City this weekend. I'm all over the place. So I need to get a website or something so y'all can keep up or actually post this shit because I've been terrible on the social media for the past month or so. But it's all good. There's some openings coming up. I got a big hole on my schedule now. So we're going to be doing more. I'll be helping. I need to keep you guys informed. I'll do better. I promise I will. But until the next time we see you guys, next week we playing a game. I can't wait for that. It's going to be great. Telestrations is coming. G, are you ready for Telestrations? Jesus. Oh, but if it was Telestrations for science, you'd be there with fucking bow tie on. Just Hey, until next time, guys, here's mud in your eyes. Thanks for watching the Gray Area Podcast. Peace.
Thanks for listening. You can find more episodes and all of our other Hot Pie Media originals baked fresh daily at our home online at hotpiemedia.com, the Hot Pie Media YouTube channel, or wherever you listen to podcasts.